In this quick tutorial, we'll show you how to run an independent samples t-test in SPSS and how to interpret the results. The dataset for this test needs to include a dependent variable in one column and a grouping variable in another column. We're using a hypothetical dataset where frisbee throwing distance is the dependent variable and dog owner is the grouping variable. We want to find out whether owning a dog has any effect on frisbee throwing ability. To run the independent samples t-test in SPSS, we go to Analyze, Compare Means and Proportions, then Independent Samples t-test. This opens the dialog box you see on screen. To perform the test, we move our dependent variable, frisbee throwing distance, into the test variables box, and our grouping variable, dog owner, into the grouping variable box. This screenshot shows you what goes where. To move the variables over, you can either drag and drop them or use the arrow buttons. Next, we click Define Groups. We input the values that define the groups in our grouping variable. In our dataset, no dog is coded as 0 and owns dog is coded as 1, so we'll input 0 for group 1 and 1 for group 2. If your grouping variable is a string type like owns cat in our example, you'll need to type it exactly as it appears in the data view. For example, we'd have to input owns cat with an uppercase O and an uppercase C with a space between owns and cat. Next, we click Continue. Estimate effect sizes is checked by default. We want to leave it like that. Finally, we click OK to run the test. The SPSS output viewer will pop up with the results of our test. The output contains 3 tables. First, in the group statistics table, we see that people who own dogs have a mean frisbee throwing distance of 58.20 meters. For those who don't own dogs, it's lower, 40.49 meters. Before we check whether this difference is statistically significant, we want to look at Levine's test for equality of variances, which is in the independent samples test table. The independent samples t-test assumes that the variance of the dependent variable, frisbee throwing distance, is equal across the 2 groups, people who own dogs and people who don't own dogs. Levine's test checks this assumption. In our example, Levine's test gives an f-value of 2.394 and a significance value or p-value of 0.133. Since 0.133 is greater than 0.05, we can assume equal variances. This means we can use the top row of results in the independent samples test table when interpreting our t-test results. Now, looking at that row, we see a t-value of minus 2.694 and a p-value of 0.012. Since 0.012 is less than our alpha level of 0.05, we conclude that the difference in frisbee throwing distance is statistically significant. Just as a reminder, a p-value that is less than or equal to our alpha level is statistically significant. However, a p-value that is greater than our alpha level is not statistically significant. Finally, let's review the independent samples effect sizes table. This table gives us Cohen's d, a measure of effect size. In other words, it tells us how large the difference between the groups is. We want to look at the value under point estimate. In our example, Cohen's d is minus 0.984. The negative sign just tells us the direction of the difference. In this case, it means that dog owners threw further than non-dog owners, but what matters for effect size is the number's size, not its sign. Minus 0.984 is considered a large effect size based on the conventional benchmarks which are displayed on screen. In our example, this suggests that there is a large difference between the frisbee throwing abilities of dog owners and those of people who don't own dogs. Thanks for watching. If you found this video helpful, don't forget to like and subscribe.